This is Maui Community College, with a world of knowledge here at home.
Well, the purpose of all this video is this right here. I get this question a lot. Somebody will come home and sit down and ask me this question right here, and the answer is always the same. That depends on the clinical situation every single time. So should the water seal bubble? Well, is air coming from a pneumothorax that we're treating? If the chest tube is for a pneumothorax, then we can expect air to bubble in the water seal, but we want that to decrease over time, meaning that the leak is getting less. Is the air leak coming from a leak in the chest tube system due to a bad connection or a leak at the insertion site? Well, if we have the chest tube set to suction, then a leak in the chest tube system, a leak at the insertion site, will make the water seal bubble. So if the system is set up for suction, a sudden increase in bubbling in the water seal can show that the chest tube has become disconnected. If it's not set to suction, we can use our little inspiratory pressure gauge to make sure that the chest tube is properly connected. Well, when should the water seal stop bubbling? Well, the best case scenario is the air stopped because the punctured lung is now healed and our pneumothorax is all resolved and everything's all better. That's a great reason for the water seal to stop bubbling, whether it's got suction or not. Has the air stopped because there's a chest tube obstruction? Well, do you remember tension pneumothorax? People with chest tubes in them can develop tension pneumothorax if the chest tube becomes obstructed. And so that's why you need to understand how the system works and what it's being used for and what was going on just a few hours ago to be able to answer this question. So whether the water seal should bubble or not depends on the clinical situation every time. And the point that I want to make is that any changes in the chest tube output should be reported immediately. So we've talked about the collection system. We've talked about the water seal. Let's talk about suction control. All right. Before we do, if a chest tube system has no suction, then it's automatically set to water seal. All right. So we don't really have to have suction on this system for the water seal to work. But for us to have suction on the system, we want to have control over the suction, and that's the purpose of Bottle 3, the suction control. Here is the third chamber on this system, and it's considered the suction control or the vacuum control. So a suction control chamber allows for the precise control of suction placed on any system. So when we take a chest tube system and we hook it up to our wall suction, if we have a suction control device, we will not be able to apply too much pressure, too much suction on the chest tube system, and that's what this is for. All right, so the air comes into the suction control from the chest tube system, and then the wall suction is connected to the output. But notice there is a vent in the center, and this vent is also called the atmospheric vent. It's also called the safety valve of the suction system. And the atmospheric vent of the suction is usually submerged in 20 centimeters of water. All right, don't confuse this with the water seal. It's not the water seal. It's the suction control that's submerged in 20 centimeters of water. Notice here the atmospheric vent of the suction system is usually submerged in 20 centimeters of water. If you look at these very carefully, you'll see the suction control is set for 20 centimeters of water. Sure, there's going to be people that want it varied a little bit, but 99% of the time, you're going to see 20 centimeters of water for suction control. So let's talk about how that works. by placing the atmospheric vent underneath 20 centimeters of water and applying suction until the vent begins to bubble, then we are assured that it's a consistent suction of exactly 20 centimeters of water is applied to the chest tube system. Because this is under 20 centimeters of water, if we apply any more suction than 20 centimeters of water, we're going to make it bubble. But this will still have precisely 20 centimeters of water of negative pressure applied to the system. 20 centimeters of water suction applied to the system. We can turn the wall suction up full blast, and it's only going to make the suction control bubble more. The chest tube is going to stay completely consistent at 20 centimeters of water. So once the suction control vent bubbles, there's no more wall suction necessary. If the suction is less than 20 centimeters of water or turned off, the suction control will not bubble, and that applies to any of the systems. If we do not place enough suction on the system, the control chamber will not bubble. If we turn the suction completely off, the water seal will still function, but the control chamber will not bubble. So when we stop the suction, the system, we say, is set to water seal. And so if there is no suction, there is no purpose to a suction control bottle. So the suction control chamber should bubble when the proper amount of wall suction is applied. Once we've applied the proper amount of wall suction, the suction chamber will bubble, and we don't need to make it bubble anymore. If the suction control chamber is not connected to suction, then the suction control chamber will not bubble. But all that bubbles, it makes a lot of noise, and that tends to keep people awake. And if you kick them over, it tends to be a problem. And something we see more and more used is something called a dry chest tube system. It's exactly the same, has a collection bottle and a water seal, just like every other system. But here it has dry suction control. So here's our collection chamber. It's exactly the same. The water seal is exactly the same. But what's different with this system is what's called a dry suction control. And so we'll blow that up. It has a little thumb wheel on the side of the device. You can change this if you're ordered to. But usually it's set for 20 centimeters of water suction, which is negative 20 centimeters of pressure water. And so this is a dry system, and we see it's set for 20 centimeters of water. Notice it's set for about 20 centimeters of water. We can't set it exactly. We just kind of have to guesstimate that that's about 20 centimeters of water, which is fine. And then under here is an indicator showing if the proper amount of suction has been applied. And so if we take that and draw a cartoon of it, once the proper amount of suction has been applied, an indicator, a little bellows, will open up and come right out to the line. That tells us the proper amount of suction has been applied. If we don't apply suction to the chest tube system, the bellows will go back in. And we'll just look at it one more time. So this is the indicator showing us that the proper amount of suction has been applied to the dry suction control. And so a dry suction control tube system has everything the same, but it just does not use water for suction control.